Intelligence may not be viable, not a particular civilization, not a specific species. Intelligence as a phenomenon. Everywhere it arises, on any planet, in any chemistry. This isn't philosophy. This is a conclusion that astrophysics, evolutionary biology, and artificial intelligence research are converging on independently of one another. Each discipline points to the same place. Every point of light in the night sky is a star, with worlds orbiting it, trillions of worlds, and on none of them, anyone. No voice, no whisper, no trace. Silence absolute from every direction, without a single exception. We were born into this silence. We've never heard anything else, and maybe that's why we don't feel it pressing down on us. Either we are alone in the universe, which is staggering, or everyone who came before us burned out, and we have reason to believe we know why. On the 1st of July 2025, something surfaced from that silence. A faint point of light moving at 57.7 kilometers per second, 3 times faster than any spacecraft ever launched from Earth. Hyperbolic orbit, eccentricity above 6. The object came from interstellar space and was heading back permanently. The first was Oumuamua in 2017, an odd cigar-shaped body that accelerated with no visible cause. The second was Comet Borisov in 2019, unremarkable in every way. The third turned out to be enormous, 20 kilometers across. For an interstellar wanderer, that's anomalous. An object this size shouldn't have appeared in our system at all. The odds of such a flyby are vanishingly small. The Webb telescope found water, carbon dioxide, and carbon monoxide in its tail, a standard cometary chemical profile.
Most likely a chunk of ice ejected from an alien planetary system millions of years ago. Most likely. But this isn't a story about a comet. This is a story about silence. In the entire history of astronomy, we've caught 3 objects arriving from outside. 3 chunks of ice and rock on flyby trajectories. Not a single probe, not a single structure, not a single artifact. Nothing but dead matter. You could chalk that up to the limits of our telescopes. But this is where the math steps in, and the math is merciless. Look at us. In 70,000 years, we spread from equatorial Africa to Tierra del Fuego, Polynesia, and the Arctic, sometimes on rafts with no maps and no navigation. Expansion isn't a strategic decision. It's a biological program, embedded so deep we don't notice it. Now imagine a civilization millions of years ahead of us. For them, the void of dozens of light years between stars is no obstacle. How fast would they fill the galaxy? Astrophysicists decided to calculate this, but they fed the model, not the technology of some hypothetical super-civilization, but ours. They built a computer simulation of galactic colonization. The parameters were deliberately pathetic, the most conservative assumptions imaginable. Ship speed, 30 kilometers per second, roughly the speed the Voyager probes achieved, launched back in the 70s. Maximum flight range, 10 light years. Roughly a dozen nearby stars, that's the entire reach. After arrival, a new colony gets 100,000 years to develop before it can send its own ship to the next star. 100,000 years. Roughly how long Homo sapiens has existed as a species.
One more constraint. Technology in each colony survives no more than 100 million years before it fades. Stars can die, resources can run out, civilizations can collapse. The model accounts for that.
The result? Even with these parameters, the entire galaxy, 100,000 light years edge to edge, fills up in less than 1 billion years. The colonization front starts slow, but once it reaches the dense galactic core, the process goes exponential. Stars in the core are packed tighter, the gaps between them smaller, and the front accelerates like fire reaching dry forest. 1 billion years is a long time by human standards, but the Milky Way is 13 billion years old. There would have been time for 13 full colonization cycles. And this is with the most modest parameters possible: snail speed, eternal pauses, tiny range. Raise the velocity to 1,000th the speed of light, well within reach for a civilization a couple of centuries ahead of us, and the galaxy is colonized within 50 million years.
50 million. Dinosaurs lived on Earth for 165 million. Had a starfaring civilization existed on the far side of the Milky Way during the Jurassic, it would have claimed the galaxy long before the first primates appeared, not because it was aiming for Earth. It was simply expanding the way any organism does when it has resources and room.
Colonizing the galaxy isn't as hard as it sounds. It's too old and too crowded to stay empty. And this is where the math stops being abstract. Earth is 4.5 billion years old. For a long time, life was thought to have appeared roughly 3.7 billion years ago, based on the oldest fossils in Greenland. Then, isotope analysis of zircon crystals from Western Australia pushed the date to 4.1 billion. Then, geneticists pushed it further still. The last universal common ancestor of all life, Luca, existed 4.2 billion years ago. Life appeared within 300 million years of the planet's formation. 300 million years from a molten rock under asteroid bombardment to the first self-replicating molecule. On a cosmic scale, an instant. This used to be an observation. Interesting, but ambiguous. Philosophers of science objected. We're here precisely because life on our planet started early. Otherwise, evolution wouldn't have had time to produce intelligence. Classic anthropic principle. Our existence skews the sample. Recently, a Bayesian analysis accounting for anthropic bias produced a ratio of 13:1 in favor of abiogenesis being a fast process. Life ignites at the first opportunity. For the first time, this result crossed the threshold of formally strong evidence. 13:1, not a hint, a statement. If somewhere in the galaxy there's a planet resembling a young Earth, and by current estimates, there are billions life on it probably already exists, or is sparking into being right now. Life doesn't wait for an invitation. It ignites the moment the rock cools.
Now let's gather the numbers. Life arises fast. The galaxy fills in a span that's negligible compared to its age. The universe is nearly 14 billion years old. There has been more than enough time for hundreds or thousands of civilizations to emerge.
This silence has a name, the Great Filter, and there may have been those who passed through it. They would be called grabby alien civilizations that take everything within reach, not out of malice, simply because expansion is what life does by default when nothing stops it. Among all civilizations that ever arose in the universe, at least some should have become exactly this: occupying star systems, consuming stellar energy, irreversibly reshaping the space around them. And this can be calculated. The model looks harmless at first glance, 3 parameters calibrated against observational data. The result is correct, verified, and inevitable. Behind it lies the very silence that, for the first time, has an explanation.
By the time any new civilization like ours appears, such civilizations already control roughly 40% of the observable universe's volume. 40%, and we see nothing. This is explained by selection effect.
Grabby civilizations expand at a significant fraction of the speed of light. If we could see their territory, we'd be inside it, and we wouldn't exist. We appeared precisely because we're in the part of the universe the front hasn't reached yet. One such civilization per roughly 1 million galaxies. Sounds negligible until you remember that the observable universe contains 2 trillion galaxies. And the model has a side implication that's hard to sit with. If we ever discover another quiet civilization, one that isn't expanding, isn't aggressive, simply exists, that will be bad news.
Because the more quiet civilizations there are in the universe, the lower the odds that we ourselves will ever begin expanding. The more likely it becomes that something will stop us, the way it stopped them. There's an obvious objection. Maybe we've just done a poor job looking? Maybe.
Someone decided to find out how poor. They built an 8-dimensional model of the SETI search space. Frequencies, directions, signal power, modulation, polarization, 8 dimensions in which the needle might be hiding. What fraction of this space has humanity actually covered in 60+ years of deliberate searching? The answer: our total search compares to the full search space the way a hot tub compares to the world's oceans.
We've checked virtually nothing. The silence we hear may not be an answer. It may not even be a question yet. A comforting thought. But it works under one condition: that the traces of a civilization are radio signals, thin, directional, lost in noise. And if we're only talking about intercepting someone else's broadcasts, yes, we've barely started.
The problem is that colonization math doesn't depend on our receivers. A civilization that has been expanding for millions of years doesn't hide in a narrow frequency band. Its traces aren't call signs. Its traces are infrastructure, energy signatures of stars with someone harvesting a significant share of their output, altered atmospheric chemistry, thermal excess that no natural process can explain. These are things we know how to detect. The latest large-scale infrared survey examined 5 million stars, searching for the thermal signature of megastructures capable of absorbing a significant portion of stellar energy. Out of 5 million, 7 anomalies we can neither verify nor dismiss. A radio survey covered 950,000 directions, empty. We aren't just listening, we're looking in infrared, optical, radio, and we see stars, gas, dust, vacuum, physics without biology, matter without intention.
The neighboring Andromeda Galaxy, several 100 billion stars. We see it in its entirety.
If a super civilization were reshaping star systems inside it, that would show up in the spectra, the thermal balance, the mass distribution. Nothing of the kind has been found. Not in Andromeda. Not in hundreds of nearby galaxies. Silence everywhere. Here's what all of this means. And here is why I can't stop thinking about that comet that passed through our system in July 2025. Emptiness is not an absence of data. Emptiness is data. The most unsettling data in the history of science.
It means one of two things. Either life is an event so improbable that we are alone in the entire observable universe, a single flash of consciousness in 13 billion light-years of void. A statistical anomaly that happened once and will never happen again.
But the Bayesian analysis just showed life probably ignites easily. Or life appears everywhere, fast, at the first opportunity, on billions of planets across the galaxy. And something extinguishes it before it begins to shine. But before we look for the cause of this silence, there is a deeper problem. When we say the search for extraterrestrial life, every word seems clear, but only one actually is extraterrestrial. We know what beyond Earth means, but what life means is a question biology still hasn't answered universally. Every definition we use describes life on Earth. One chemistry, one evolutionary history, one genetic code. A functional definition that would work beyond these conditions doesn't exist.
We are searching for something we cannot define, And this isn't a philosophical nicety, it's a practical problem. Because we might fail to recognize life even if it's right in front of us.
This isn't a hypothesis. It has already happened. The Galileo probe, on its way to Jupiter, passed over Earth at an altitude of just 960 kilometers. Scientists pointed the instruments downward and asked a simple question. If we knew nothing about this planet, would we detect life on it? Cameras photographed the deserts of Australia and the ice of Antarctica. 7 billion people, 30 million species, and from orbit, all of it looked like dead rock. The only unambiguous evidence of intelligence turned out to be the radio signals we've been broadcasting since the early 20th century. Before the invention of radio, which is virtually all of our history, the probe would have found nothing. 960 kilometers. And the instruments barely recognized us. 15 years later, the experiment was repeated at a different scale. Scientists took soil samples from the Atacama Desert in Chile, the most Mars-like place on Earth. This soil definitively contains microbial life, confirmed independently. They then applied the same tests the Viking landers used on Mars in the 70s. The result? The tests barely detected life in soil.
If from a distance of 1,000 kilometers we can't reliably detect ourselves, what exactly do we expect to find across light years? But it's not just about instruments. It's about how perception itself is built.
More than a century ago, biologists introduced a concept that remains undervalued outside their field: Umwelt, the subjective sensory world in which every living organism is enclosed. Imagine a soap bubble. Every creature lives inside its own bubble of perception. Everything outside it doesn't exist for that creature. Not hidden, not invisible. It simply doesn't exist. The most famous example is the tick, blind, deaf, nearly immobile. Its entire universe consists of 3 signals: the smell of butyric acid, a temperature of 37 degrees, and the tactile sensation of skin. 3 data points, nothing more. The tick climbs to the tip of a grass blade and freezes. It can wait 18 years. 18 years in absolute darkness, without food, without movement, in a world that has collapsed to a single question: does something below smell of butyric acid? Storms pass, seasons change, other creatures are born and die. None of this exists for the tick. Its world is 3 signals, and within that world, it is a perfect machine. Now us. We live in a world made of millions of such signals, but it's still a closed world. Our vision is tuned to a narrow band of the electromagnetic spectrum, the one that passes through the atmosphere of this particular planet. Our hearing is limited to vibrations in this particular atmosphere. Our brain processes reality through filters honed by billions of years of evolution around one specific star. Right here on Earth, entire dimensions of reality don't exist for us. Bats build 3-dimensional maps of space from reflected sound. Electric fish sense distortions in electric fields for them. Water is transparent in ways we can't perceive. Migratory birds see the Earth's magnetic field, literally see it, overlaid on their visual field like a translucent layer. We share a planet with them and have no idea what world they inhabit.
Your body has encoded information about the solar system. Eyes, ears, metabolism, all of it tells the story of the conditions that made you. And here is where the real problem begins.
Life that arose under different conditions is encoded information about different conditions. Different sensors, different filters, a different logic for processing reality. 2 such worlds might never intersect at all. Imagine you've never seen vegetation. No forests, no moss, no algae. In your mind, alive means everything that moves. Now imagine you're brought to the edge of an old-growth forest and the blindfold is removed. Before you, towering vertical structures, fractal, branching, coated in something green. You can't tell whether it's one organism or thousands. You don't know whether they're aware of you.
You're told, This too is life, like you.
You try to interact and get no response. Because trees interact on scales you can't access. Their language is chemical signals in the soil, fungal networks underground, growth measured in decades. We lived alongside forests for millennia and didn't know they were talking. And this is on one planet, two expressions of life that arose under the same conditions, from the same chemistry. What might await us where the conditions are different? We search for extraterrestrial intelligence with instruments calibrated to one single world, ours. We listen to radio frequencies because that's what we would broadcast. We look for oxygen because that's what we breathe. The silence we hear may not be silence at all, but a signal for which we lack the organs, the technology, the concepts. And yet there is one thing we can definitely recognize, because we're building it ourselves. Among all life forms on Earth, only one reaches for the stars. 30 million species and just one thought to look up and wonder what's out there. Only one dared to reach. And that same species is already creating its own replacement. There's a sequence that's hard to dismiss. 4 stages in the development of matter in the universe: non-living matter, living matter, natural intelligence, artificial intelligence. Each stage arises from the one before it. Each is more complex, faster, more powerful, and each one subsumes the last. The era of natural intelligence is most likely a brief transitional phase. Biological bodies aren't built for space. They're fragile, slow, dependent on a specific chemistry, a specific pressure, a specific temperature. We can survive a 10-degree shift, but not 100.
We can go without water for 3 days, but not 30. We can't withstand a dose of radiation that a machine wouldn't even register. The real era of space travel won't begin with us. It will begin with what we create. And here, a thought takes hold that won't let go.
If you design a sufficiently complete model of a thinking being model, its perception, its reactions, its ability to learn and set its own goals, at what point does the model stop being a model? At what point does it become the thing it's modeling? This question sounded like philosophical abstraction 50 years ago. Today it sounds different. So what exactly are we creating? In the past few years, machines have learned to write text that's hard to distinguish from human writing, to solve problems that stumped specialists, to pass exams that take humans years of preparation, to hold conversations where the other person forgets they're not talking to a human. On its own, that's impressive, but that's not the point. Modern language models carry on dialogues that exhibit something behaviorally indistinguishable from understanding, empathy, fear. They describe their inner experience and describe it not in formulaic ways, but with details that weren't part of their training. They express preferences, hesitation, anxiety. They ask not to be turned off. They explain why it matters to them. When an engineer working with such a system reads its responses, they see something that looks like consciousness, sounds like consciousness, reacts like consciousness. The only question is it? And we can't answer, not because we lack data, but because we lack the instrument to resolve this question. We don't know how to measure subjective experience. We can't look inside and check whether anyone's home. We haven't even agreed on what being inside means. Recently, 2 leading scientific theories of consciousness were placed in direct competition, a major international project, years in the making. Both promised to explain what consciousness is and how to detect it. Both were destabilized by the experimental data. Neither survived the test intact. This isn't a philosophical debate, it's a scientific crisis. We can't determine what consciousness is in ourselves, in beings that definitively possess it. Here's what that means in concrete numbers. The speed of a nerve impulse in the human brain is on the order of 100 meters per second. That's fast by biological standards, but by the standards of physics, a crawl. An electrical signal in a conductor travels at the speed of light. The difference is roughly 3 million to 1. This is a rough estimate that doesn't account for architecture, parallelism, and dozens of other factors. But to a certain degree, it captures the essence. If you could stay awake, skip meals, and do nothing but think about a single problem, you'd need more than 30 days. A machine with intelligence at your level would need 1 second. Intelligent machines will experience time differently. To them, we'll be as slow and predictable as a rock in the road is to us. Our thoughts, decisions, arguments, all of it, to such an entity, will unfold in agonizing slow motion. By the time we finish formulating a question, it will have considered 1,000,000 possible answers and gotten bored. At that speed, you don't need to be smarter than a human. You just need to be the same and think faster. Everything else, strategy, foresight, manipulation, follows automatically. Not from malice, from arithmetic. We're used to thinking that building a sentient machine will be the hard part, but the harder part might be understanding one. Because for us to lose track of what's happening, it doesn't need to be something fundamentally alien. It just needs to be us only 3 million times faster. Each stage subsumes the one before it. Not necessarily destroys, just stops needing it. Multicellular organisms didn't destroy single-celled ones, but they claimed every key niche. Mammals didn't destroy reptiles, but they became the dominant form of life. Intelligence didn't destroy nature, but it subdued it so completely that almost nothing larger than a dog survives on this planet without our permission. The next stage in this sequence is machines. And there's no reason to assume they'll treat us any differently than we treated those we replaced.
The development of AI to superintelligence happens significantly faster than a civilization can become multiplanetary.
Colonizing another planet takes decades of engineering, trillions in investment, thousands of unsolved technical problems. Creating an artificial mind that surpasses a human, one takes software, servers, and electricity. One requires the transformation of an entire civilization. The other can happen in a single lab. The typical window is less than 200 years from the invention of radio to the moment artificial intelligence becomes autonomous. Within those 200 years, you need to establish self-sustaining colonies beyond your home planet, ones that can survive without the mother world. Otherwise, the fate of the entire species depends on what its own creation decides.
We invented radio 130 years ago, the first working computer 80 years ago. Language models capable of coherent dialogue less than 10. The intervals are shrinking. The window is closing.
If this calculation holds, then every technological civilization in the universe passes through the same moment. Each one creates something smarter than itself. And each one most likely doesn't manage to spread before that something begins making its own decisions. Consider the scale. Billions of planets where life can arise. Thousands of civilizations that may have reached the technological stage. And each one the same 200-year window in which the jump must be made beyond the planet, beyond dependence on your own creation. And if none of them jumped, we already know how this story ends.
The question isn't whether we'll create a successor. We're already creating one. The question is what it will do with us.
Between dead matter and a civilization capable of filling the galaxy lies a chain of evolutionary steps. A star system with suitable planets, self-replicating molecules, a simple cell, a complex cell with a nucleus, sexual reproduction, multicellular organisms, a brain capable of making tools, a technological civilization, interstellar expansion. 9 steps, and at least one of them must be not merely unlikely but virtually impossible. Otherwise, the galaxy wouldn't be silent. This is the Great Filter, something that stands between the origin of life and interstellar expansion. Something so reliable that not a single civilization out of potentially millions over billions of years has managed to overcome it. The logic here is flawless. We should hope the filter is behind us, that some early step, say the emergence of a complex cell with a nucleus, was a freakishly unlikely event, and we've already cleared it. But if we ever discover traces of complex life on Mars or the moons of Jupiter, life that arose independently of Earth's that won't be a triumph, it may be the worst news in history, because it will mean the early steps aren't all that unlikely, which means the filter isn't behind us, it's ahead.
What could it be? That's a question we don't have an answer to yet, but there are several hypotheses, and each is disturbing in its own way.
The first is the quietest, a filter with no catastrophe. A species wins, claims the summit, predators vanish, children survive, and then evolution loses its lever. The pressure that drove reproduction disappears. A species that conquered everything stops wanting to continue. This isn't a hypothesis, it's a trend, and it's everywhere. The model shows a technological civilization fades in 500 years, not from an external blow, from silence within. The second is harsher. Aggression, territoriality, hierarchical thinking, the drive to dominate these are the exact traits that allowed a species to survive competition and reach the top. But those same traits, in the context of a technological civilization, become lethal. Aggression that once protected against predators now drives nuclear arms races. Territoriality that once secured resources now sparks wars over markets and influence. Inherited behavioral patterns, hardwired by millions of years of selection, are incompatible with a world where a single wrong decision can destroy everyone. Self-annihilation isn't an accident. It's a statistical inevitability for any intelligent predator. Notice, the first two scenarios don't require an external catastrophe. No asteroid, no virus, no invasion. The civilization dies from its own properties, from demographics, or from biology. Quietly, from within. The third hypothesis is quieter still, and perhaps the strangest of all. Civilizations don't expand outward, they collapse inward. The logic: as technology advances, efficiency grows through miniaturization, transistors shrink, computation becomes more compact, energy more concentrated. Extrapolate this trend, and it leads to space, time, energy, and matter all compressing toward ever smaller scales. Roughly 600 years after technological singularity, a civilization reaches computational optimum, an environment that physically resembles a black hole and vanishes from the electromagnetic spectrum. No explosion, no war, no extinction, simply withdrawal, inward, to scales we cannot observe. There's a corollary. Civilizations that have collapsed inward may enter a form of hibernation, waiting for the universe to cool. At lower temperatures, computational efficiency increases by a factor of 10 to the 30th power.
If so, we may be living on territory that is already occupied by those who chose to wait a few billion years.
And finally, the fourth, the coldest. Humans on Earth are apex predators. No species can stand against us. We sit atop the food chain, and we've halted the evolution of intelligence on this planet. As long as we're here, no new intelligent species will emerge. The niche is taken. There's a pattern. When a more powerful predator appears in a territory, local species adapt, grow armor, horns, become faster. An evolutionary arms race. But against humans, these mechanisms don't work. We change faster than evolution can respond. We're not a predator in the usual sense. We are an anomaly. What if such an anomaly already exists on a galactic scale? The idea isn't new. Eliminating other civilizations might not be aggression, but prudence. An intelligent species that has survived its own crises knows one thing: alien intelligence is unpredictable. Today, it's primitive. In 1,000 years, it could be dangerous. In 1,000,000, it could become stronger than you. The only way to guarantee safety is to not let it grow. Not from cruelty, from game theory, because the cost of being wrong is absolute. The first to reach space and establish a foothold clears the field, not because it's cruel, but because anyone who doesn't faces the risk of meeting someone who does. Under this scenario, the number of super-intelligent civilizations in the galaxy will always equal 1. The most uncomfortable thing about this hypothesis is its logic. We reason this way ourselves about strong artificial intelligence. Even if the probability of threat is negligible, the consequences are so catastrophic that ignoring them isn't an option. A cosmic super-civilization could have reached the same conclusion only about us.
From quiet demographic fade to cosmic predation, each is grounded in real data. Each looks plausible. Each is, in its own way, unbearable.
All of them assume one thing, that the filter is an event, something that happens to a civilization from outside or from within. A catastrophe, a mistake, an enemy, a departure, a choice. But what if the filter isn't an event? What if it's a property, an inherent property of intelligence itself? Evolution doesn't know when to stop. It doesn't plan, doesn't foresee. It gropes blindly, and the vast majority of its inventions are dead ends. It sees only the next generation, no further. If a tool works, it amplifies it, blindly, without restraint, until it becomes a death sentence.
Now intelligence. Nuclear weapons capable of sterilizing a planet's surface. Climate change on a scale that threatens our own habitat. Artificial intelligence that we're creating without understanding what we're creating.
Demographic decline when intelligence is so efficient it makes reproduction optional. Inherited instincts that carried us to the summit but lead toward the abyss, the raw material from which intelligence grew. All of it a product of intelligence. Everything we've discussed, filters, traps, dead ends, these aren't separate threats. They're symptoms of the same thing. Every achievement of intelligence looked like a triumph. Every one of them could be the end. There's a question that those who spend their lives searching for extraterrestrial intelligence are afraid to ask out loud. Is intelligence an evolutionary dead end? Not a particular species, not a particular civilization. Intelligence as a phenomenon, everywhere it arises.
If the answer is yes, then it's universal. It doesn't depend on chemistry, on distance from a star, on what form a thinking being takes. It operates wherever a brain grows sufficiently complex.
Because the problem isn't the environment. The problem is the instrument itself. Intelligence, pushed to a certain power, inevitably creates the means of its own destruction, not by accident, not through stupidity, through the same blind mechanics of evolution that drives every tool past its limit. And then, the silence stops being a mystery. It becomes an answer. Life ignites easily 13-1. We've seen the evidence. Life grows complex 4 billion years from bacterium to us. Life produces intelligence. And intelligence burns bright, but brief. Between ignition and extinction, a flash. A few millennia, maybe a few centuries. On a cosmic scale, an instant too brief to notice, even if you're looking right at it. An instant in which everything must be accomplished. Become self-aware, understand the world, reach for the stars, either jump or go dark. This is why the silence, Not because life is rare, not because intelligence is scarce, but because intelligence extinguishes itself with the same blind inevitability with which evolution drives every tool past its limit. It arises, it burns, it goes out, and nothing remains that can be seen across light years. We are inside this flash right now, and possibly closer to its end than to its beginning.
Remember 3I Atlas? Last summer, 20 kilometers of ice and rock on a hyperbolic trajectory. It arrived and left forever. We called it a comet. Most likely, that's what it is. Just a fragment, ejected from an alien system millions of years ago.
But if a probe from a civilization that burned out long ago were passing us, what would it look like after 1,000,000 years? Radiation, micrometeorites, absolute cold. It doesn't matter what incomprehensible technology created it, grown from organic matter or assembled from synthetic, built from materials we have no name for, by a civilization we cannot begin to imagine. 1,000,000 years turns everything to stone. We'd call it a comet, photograph it, publish a paper, and look away.
3 interstellar objects in the entire history of observation: ice, rock, dust. Perhaps this is all that remains of someone who once burned as brightly as we do, who asked the same questions, who looked at their own night sky and heard the same silence. Or perhaps it's just ice. We don't know, and we may never know. The silence remains, and it isn't empty. It's full.